Welcome back. We are talking about wastewater treatment, under which we are discussing a number of treatment operations, secondary treatment. In this video, we will be talking about some sample calculations. When you are dealing with activated sludge process calculations, we may have to use a number of conversions. The concentration somewhere it is expressed as milligrams per liter, and they desire to have in kilograms. Similarly, sometimes volume is given in liters, and somewhere it is MLD, somewhere it is meter cube. So we have to put everything in a proper order. Then only we will have a correct solution. And then that's the reason we take up small sample calculations in this video. And the first calculation we take as design determination of soluble BOD and process efficiency. The soluble BOD is the term which is different from influent BOD. The influent BOD is the total BOD, where soluble portion is slightly different compared to the actual BOD5, which we determine in the lab. So inlet BOD and soluble inlet BOD both are similar, but after the treatment is completed, the biological treatment, whatever the effluent BOD, what is going out, it is not actually the soluble effluent BOD. Where some solids will also be escaping from the effluent. So that part we have to take care of and calculate the soluble effluent BOD. We will see those calculations in this problem. In activated sludge process, the effluent solids are 20 milligrams per liter. Inlet BOD is equal to 300 milligrams per liter. Effluent BOD5 is 30 milligrams per liter. And the plant is handling 1000 meter cube per day of sewage. Calculate the soluble BOD at inlet and outlet. Calculate the overall process removal efficiency in terms of soluble BOD and overall BOD removal. So let us write all these things first. Inlet BOD 300 milligram per liter, outlet BOD is 30 milligram per liter, outlet solids 20 milligrams per liter. So the soluble effluent BOD SE we have to calculate such that effluent BOD minus 0.63 times effluent solids concentration. So we will get 17.4 milligrams per liter. Effluent BOD is 30 milligram per liter and effluent solids 20 milligram per liter. Using this equation, calculate the SE is equal to 17.4. As I mentioned, the soluble BOD of influent and influent BOD5 both are similar. So 300 milligrams per liter. Now calculate the process removal efficiency. The removal of soluble BOD S0 minus SE with respect to initial BOD, soluble BOD S0, and multiply by 100 to convert into fraction percentage efficiency. 300 minus 17.4 by 300 into 100, 94.2 is the efficiency based on soluble BOD. And efficiency based on overall BOD is L0 minus LE by L0 into 100. So 300 minus 30 by 300 into 100 is equal to 90%. Determination of solids retention time. In the calculation, some mass balance is also required. So we'll see that mass balance and conversion, particularly conversion things we will take into consideration. The SRT in aeration tank, you have to determine for a complete mixed process if volume of the tank is equal to 500 meter cube, MLS is 3000 milligrams per liter, recycled sludge 10,000 milligrams per liter, effluent solids 20 milligrams per liter, flow rate is 1000 milligrams, 1000 meter cube per day, and waste flow rate is given as a 10 meter cube per day. So calculate the SRT if the discharge from effluent line is neglected. So first of all, we write all the values here. V is equal to 500 meter cube, X is equal to, this is MLS, Xs means nothing but MLSs. Effluent solids Xe and recycled sludge XR, influent flow rate 1000, waste flow rate 10 meter cube per day. So SRT is defined as the total amount of solids retained in the system divided by solids wasted from the sludge line and solids wasted from the effluent line. So Q minus QW is the amount of water going out from this clarifier if the Xe has a solids concentration. And QW is this water waste to flow rate coming from the sludge line with the XR as the solids concentration. V is the volume of the tank and area X is the MLSs. So now we'll calculate these values. So for simplicity, we'll take Vx, QW, XR and other things separately and we'll substitute to calculate the SRT. Okay, 5Vx is equal to 500 meter cube, 3000 milligrams per liter. So here it is mentioned as meter cube, here is mentioned as a liter. So you have to put the appropriate conversions. 1000 liters per meter cube. It comes out to be 1500 into 10 to the power of 6 milligrams, which is equal to 1500 kilograms because we know 1 kilogram is equal to 10 to the power of 6 milligrams. Similarly, QWXR is equal to 10 meter cube per day with the waste flow rate and XR 10,000 milligram per liter. And again here meter cube and liters. So you have to apply the conversion. So 1000 liters per meter cube. It comes out to be 100 into 10 to the power of 6 milligrams, which is equal to 100 kgs per day. So Q minus QW into Xe. So Q is 1000 meter cube per day and QW is 10 meter cube per day. And Xe is 20 milligram per liter. And here also once again meter cube and liters are coming. So we have to put the liters per meter cube. Liters per meter cube. So this is equals to 19.8 into 10 to the power of 6 milligrams per day, which is equal to 19.8 kilogram per day. Substituting SRT is equal to 1500 divided by 100 plus 19.8, 12.52 days. So the second part is if the effluent line is neglected, so Q minus QW Xe is neglected, so SRT will be equal to Vx by QW XR, so which is equal to 15 days. So there's not much of a difference. The determination of SRT volume and sludge wasted. So determine the volume of an aeration tank in a plug flow process if inlet soluble BOD 200 milligram per liter, effluent soluble BOD 6 milligram per liter, and flow rate is 15,000 meter cube per day or 15 mld. Growth coefficient is 0.6 and decay constant is 0.05. Average MLSS is 300,000 milligrams per liter. Assume SRT is equal to 10 days. Compute the sludge produced in the system. Whenever the soluble BOD component is there, then we have to use these two constants, the growth rate constants, Y and KD. So accordingly, we have to write the equation. V is equal to YQ into SRT divided by X into S naught minus SC is equal to 1 plus KD into SRT. So we have written all the given data and the only thing is you have to substitute here. So while using the kinetic growth equations, another important thing is we should use MLVSS instead of MLSS. So MLVSS divided by MLSS is equal to 0.8 is MLVSS is 80% of MLSS. So MLSS is 3000 and you multiply with 0.8, you are going to get 2400 milligram per liter as the average MLVSS concentration in the aeration tank. So now let us start doing the calculations. And then we take the solids concentration also to the left hand side, because it's the denominator side in the right hand. So Vx is equal to y, this is the y, this is the q, and this is SRT, this is S naught minus SS, and 1 plus SRT into KD. So now using this, what I'm getting is Vx is equal to 11,640 into 10 to the power of 6 milligrams per day. So that V is equal to the right hand side divided by X. X we already calculated in terms of mLVSS, which is equal to 2400 milligrams per liter. So subsequently, V is equal to 4.85 in 10 to the power of 6 liters, and which is equal to 4,850 meter cube. Here we are writing because of conversion, 1 meter cube is equal to 1000 liters. So using this conversion, we are now changing the liters into once again back to meter cube. And solids produced Vx is equal to Vx by SRT. Vx we already calculated here, and SRT is equal to 10 days. 11,640 10 to the power of 6 divided by 10. So 1164 in 10 to the power of 6 milligrams per day. This is equal to 1164 kg per day. And what we have done is this wasted in terms of mLVSS. We want to calculate in terms of MLSS, then I have to go with the conversion factor of mLVSS and MLSS. So divided by 0.8 will give you the MLSS 1455 kg per day. Oxygen requirement. This is another important parameter in the activated sludge process. Determine the oxygen requirement for the following data. This is influent soluble BOD 200 milligram per liter, effluent soluble BOD 5 milligram per liter, inlet BOD is 200 milligram per liter, outlet BOD is 15 milligram per liter, solids wasted as mLVSS is 1200 kg per day, and waste flow is 15 mld. So we have the equation oxygen requirement in kilogram per day as 1.47 Q into S naught minus SC minus 1.42 into Vx in terms of soluble BOD. If we are going with only effluent BOD, we will be replacing this S naught minus SC with the L naught minus LE, that is nothing but your 5-day BOD. But what is this 1.47? 1.47 is the conversion factor from 5-day BOD to ultimate BOD. So this is a soluble 5-day BOD. Now converting into ultimate BOD, we are putting a 1.47 as a conversion factor here. And 1.42 is the efficiency of solids destruction. So 1.47 into Q into S naught minus SC is equal to 1.47 into 15,000 mld. Okay. 15,000 meter cube per day we are considering here. We are 15 mld, 15 10 to the power of 6. And then S naught minus SC is 200 minus 5. This is equal to 4153.5 kilograms per day. And second term we calculate here. So this is 1.42 into Vx, 1.42 into 1200 kg per day in terms of mLVS is already given here. 1704 kilograms per day. So oxygen required is nothing but no subtraction of first and second terms, which is equal to around 2450 kilograms per day. It's a rounded off value. So now in terms of BOD ultimate removed, instead of soluble BOD, if we consider only the 5-day BOD, how much is going to be the difference here? It comes out to be the first term will be 4080 kg per day instead of 4153.5 kg per day. And oxygen required will be difference of these two terms. It is around 2376 kg per day. And Determination of volume of the sludge wasted. How much volume of the sludge wasted from the activated sludge process we have to calculate in this problem. The solids wasted as MLVSS is 1200 kg per day. Waste flow is 15 MLD. SRT is equal to 10 days. Return sludge 10,000 milligram per liter as MLSS. This is more important. Here we are given MLVSS one place, and here we are talking about MLSS. And the ratio MLVSS is equal to 80% of MLSS. Volume of sludge wasted we are represent in terms of QW. And the approximate equation for SRT is equal to Vx by QWXR. There are some other terms, that is, we have to consider the wasting of the solids from the effluent line. So we are neglecting that part. So SRT is equal to Vx by QWXR, and QW is equal to Vx by SRT into XR. So here XR is equal to 10,000 milligram per liter as MLSS, but it should be converted into MLVSS because solids waste is given as MLVSS. So this is equal to 80% of this 8,000 milligram per liter as MLVSS. So therefore QW is equal to 1200 10 to the power of 6 milligrams per day. Then 10 days into 8,000 milligram per liter, because 1200 kg per day now converted into milligram per day, because denominator we are having milligrams. So finally what you are getting is 15,000 liters per day. So therefore QW is equal to 15 meter cube per day, because 1 meter cube is equal to 1000 liters. Thank you. This is how we calculate the simple calculations of a